Hey guys, this is Lego Masta 99 here again today, and we are right now looking at a sign that says, "The guy who is bored." Guy who is bored's what, you may wonder? Well, if we just go over here a little bit. Ooh, Redstone. Okay, we're getting somewhere. Computer version 4. Okay, so that was a really bad intro. But, yeah, I'm back, and as you can see here, if I pan the camera around and if I'm starting to get some lag spikes, but if I go like this and move around, wow, will you look at that. So yeah, I'm very sorry for the inactivity recently. I've been really busy with school, blah blah blah, the usual deal, but winter vacation, so now I am back better than ever, and I wanted to show you guys this. So this is indeed as the, oh my gosh, the lag is getting real. As it says on here, Redstone Computer version 4.0, and yeah, you can see here I dated these. Started almost a year ago, and it was finished earlier, but then I've been doing a lot of debugging with this version. So yeah, the reason why the dates are so old is because I got really busy with school, and I wasn't able to record or do YouTube videos or anything like that. So now that it's winter break, I'm able to do those things, and you guys also may notice that my voice or my microphone may sound a little different, and I'm trying out different microphones and stuff. So yeah, this is the Blue Yeti that I'm using right now, if you guys are curious. So if you guys would put your feedback in the comments below, that'll be much appreciated. So yeah, this is my Redstone Computer version 4.0. Now I guess as you can see here, it looks very interesting, just like how the Redstone Computer 3.0 was, where we have all these different UI elements and such. So I guess I'll just go ahead and start giving you guys a tour of this thing, and then I'll show you how it works. And I know you guys want to see comparisons from the Redstone Computer 3.0 to this computer, so I will also be doing those. And yeah, let's get right into it. Also, before I start our tour of this computer and how it works and everything, I was keeping a look at my YouTube numbers even though I was at school still, and I noticed that we passed 200 subscribers. Like that, oops. That is incredible. Like, I am amazed that 200 people would subscribe to a channel like mine and, yeah, be interested in me, actually. Like, yeah, it just blows my mind, you know? So, I just wanted to give you guys a huge thank you for that, and I guess you could consider this Redstone Computer 4.0 as a 200 subscriber special, I guess, since the Redstone Computer 3.0 was the 100 subscriber special. So yeah, just thank you very much, guys. I really appreciate it. So now that that's out of the way, let's get into the video. Alright, so the Redstone Computer version 4.0 is the successor to the Redstone Computer 3.0, and I guess the first thing we'll do is just give a physical tour around this behemoth, because as you can see, it is a lot bigger than the Redstone Computer 3.0. So if we just go around here, I'll just fly by here. Now, this computer also is a, quote, I'm going to be very careful when I say this, quote-unquote quad core, because I know a lot of you guys in the comments gave me ham when I said quad core the first time with the Redstone Computer 3.0, so be very careful in saying that. So if you want me to be more accurate, I will say 4 ALU computer. So it's, oh my gosh, the lag is real, so I'm just going to keep that my debug screen up. So as you can see, this is running in 1.11, but I started development of this a lot earlier, as you probably saw in those signs over there. So yeah, so as again, I'll show you these 4 ALUs, or quote-unquote cores. So there's 1, 2, 3, and 4, and so those are the 4 ALUs. The RAM is down here. Now this computer has 31 bytes of RAM instead of 15 bytes of RAM from the Redstone Computer 3.0. And this RAM, again, is dual read, so that's good. And I will mention before I forget that this computer is also an 8-bit computer. I do not really see any benefit of going over 8-bit, so I'm just keeping all my computer science stuff 8-bit. So we have our 4 cores, ALUs there. We have a GPU now. And I'm really happy to say this because I've put a lot of work into this GPU. Now, this GPU design, this or quote-unquote plotter, is not my design. It is Benny Cube's design. So if you guys will give him some love, that would be great. But I did modify this somewhat. Oh my goodness, my frame rate is absolutely being crushed right now. Okay, so yeah, this I made some modifications to it, but the core design is Benny cubes, so I just want to give him credit for that. So this is a 15 by 15 pixel display, and there are full GPU controls and full GPU controls in the instruction set, which I will talk about later. Now, as you can see here, there's also a 3-digit decimal display running off of BCD and and then here we have an 8-bit binary display as well, the same as in the Redstone Computer 3.0. And all right, so that is the outputs we have there, and over there is the UI panel, as you guys probably saw. Now, this big thing over here is none other than the program memory. Now, it is admittedly massive, and this program memory is, well, this computer has 28.168 kilobytes of total program memory. Now, I can't remember that number by myself, so I'm reading off a note I have on some notes I have here. But each core has 5.292 kilobytes of, I guess, memory, because of space per core. So this is 63 lines of code basically, and the instruction set is a lot more elongated, as you can see in my frame rate is absolutely getting destroyed here. So you have to go here, see 63 and 63, and this instruction set also has full GPU integration. So the GPU was planned to be in this computer, unlike the Redstone Computer 3.0. So yeah, I'm really happy about that. So this has 4 spaces for program memory, and now if we go down into this mess, this is the main computer, or the processing unit and stuff. So these are the buses that connect all of the ALUs together, and it runs off of the same core designs as the Redstone Computer 3.0, having a master output bus and having shared RAM and stuff. And yeah, and also I forgot, this Redstone Computer also has PIP and POP ports, as I was explaining in my Redstone Computer 3.0. So POP, parallel output port, and PIP, parallel input port right here, so you can send data in and out from those ports to communicate with the computer. And let's see here, these ALUs, each one of them now, instead of just having the RAM as memory, each ALU now has a cache, and I found it somewhat beneficial. So I designed this cache here, and it sits right on top of the ALU. So if we actually, I think it'll be a better view if we go back here. The ALU is in orange, so that is this part right here, this whole orange block, if you go all the way around like that. And all of this gray and pink stuff up here is the cache, and then the pink is the cache controller. So each ALU now has its own dedicated memory, although it's not much, but it's dedicated memory, and it's also dual read. So it's very useful for programs and stuff. If you want to run multiple programs at once, and then you can just have the program be completely independent of ALUs, and so that you don't, you can run basically different programs on different ALUs, and yeah, it can get very interesting, and it adds a whole new layer of capability with the computer. Now, each ALU has 8 bytes of cache, but there's 4 there's 4 dual read bytes, I guess you could call it. Yeah, I'll go into that later, so if you're confused, don't worry about that for now. And yeah, now this computer, it is a lot faster than the Redstone Computer 3.0, although it looks like it's a lot bigger and could be slower. And with the things such as the introduction of cache and just general architectural improvements will make this computer a lot faster. And if you program it correctly, it'll be very fast, and especially with the GPU, it'll be a lot better. And I'll go as far as to say as the Redstone Computer 3.0 was a prototype for this behemoth here, the Redstone Computer 4.0, since I learned a lot from the Redstone Computer 3.0, and I wanted to implement some new things and take out some things that didn't work from the Redstone Computer 3.0 into this computer. And yeah, so I guess now that you guys have seen a general overview here of the computer, we will go ahead and go in depth with the UI of this computer. Alright, so now if we go into in depth with the UI controls here, so this is the main platform where you will be controlling the computer, running it, doing inputting and outputting things, and that sort of thing. So I guess we'll start over here with the green part of the UI. So here we have our computer power controls. We have computer on, which basically turns on the computer, starts the clock. The sleep power control, which stops the clock but doesn't reset any of the memory, and then or reset any of the devices and stuff that are in use by the computer. And then the computer off, which basically clears the RAM, stops the clock, resets everything so that you can run another program. And over here we have the speed controls. Now, as in the Redstone Computer 3.0, there were speed controls, and there are also speed controls in the Redstone Computer 4.0. And this one's different, though. This one, you can set the speed, but you also here, as you can see, you can toggle software speed control. So if I turn that switch, then you're giving control of how fast the program is to the program. So there's also things in the instruction set where you can change the speed of the program if you need to run the program slower, and like let's say initialization steps, and then when the program is running in its full form, you can speed it up in the program. So yeah, it is. I like that addition. And over here we have the core toggles, and you can toggle all the cores as well as the random number generator. This has a random number generator. And now over here we have our computer inputs. Now, the way this works is that you push the button to turn on the input, like that, like see, the input's on. And then when the computer reads the input, whether it's accepted or not, it'll reset. So that'll be shown later. So then if I turn the computer off, as you can see, it resets. But it also gives me a massive amount of lag because the computer is being reset. And then over here we have our 8-bit binary input, and then I have the numbers up here, so then you can send data into your program using this. And over here we have our program output, like flags, I guess you could call it. So here, the first 4 lamps, we have our computer indicators. These are all totally programmable in the program, like you can toggle those. And then your shift overflow and underflow lamps, those will turn on if it, as it says, if the specific ALU has overflowed or underflowed. Now over here are our device controls, I guess you could call them. So here we have our reset RAM on shutdown, that you can toggle that if you want to turn the RAM on and off. Like let's say if you had a really big program and it couldn't fit in one program space, so then you utilized multiple program spaces, this would be a really good time to turn that off, so that when you turn the computer off to load the next part of that really big program, all your data doesn't get reset. And then here we have reset displays on shutdown, and when I mean displays, it's display, display, and display. So this whole thing counts as displays, and then you can toggle that. And now we have the clear decimal display register, which basically means you clear the decimal display. And then you clear the raw binary display register, which clears the raw binary display, and then clear just the GPU, or the display in general. And that'll clear it to look like this. And then over here, just the credits and stuff. And yeah, as it says here, you guys' support is extremely appreciated. I'm really thankful for you guys, so thank you again. And now, all right, I think we do not have anything else to go into except to show you guys the improvements of this computer and some demos. Oh, wait. I forgot something. All right. Up here, we have the core instruction info indicator lights. In the last Redstone Computer, I call them like the line of code indicators, I think. So here, basically, we'll display what line of code the specified ALU is running. So as you can see here, core 1 or ALU 1, core 2, ALU 2, core 3 or ALU 3, and then core 4 or ALU 4. And then, yeah, you'll be able to see that. And yeah, so now I guess we will get into the programs and some demos and such. Alright, so what you guys are seeing here is a comparison of the a multiplication program between the Redstone Computer 4.0, which is at the top, and the Redstone Computer 3.0, which is at the bottom. Now, as you can see, I have a timer going on the top right corners of both of them to see which one is faster, and we can compare the two speeds. Now, each program is basically the same multiplication program, but the Redstone Computer 4.0 has architectural improvements built in, and it's multiplying the same numbers 7 times 7, and then we all know that answer is 49, but we're going to basically wait and see until and see which computer gives the answer first. And you guys probably know which computer it is already, but you guys will be able to see the differences between the two, and if you program it correctly, you'll be able to see the performance gains of
the Redstone Computer 4.0. Now, as you can see, the Redstone Computer 4.0 finished first with a time of 8 minutes and 18 seconds, and then the Redstone Computer 3.0 will finish shortly after with a time of 9 minutes and 51 seconds. Alright, so what you guys are seeing here is the Redstone Computer 3.0 and the Redstone Computer 4.0 running the Fibonacci sequence program. Now, these again are pretty much identical programs, except the Redstone Computer 4.0 has architectural improvements built into the program. And as you can see, the Redstone Computer 4.0 isn't as fast this time, but it is still faster and in the lead than the Redstone Computer 3.0. And yeah, I think this will show you the more minute differences, but this is pretty much running the same exact program, and you're able to run the programs at a faster speed, and you're also able to see the benefits of these programs. And as you can see, the Redstone Computer 4.0 finished first, and that one finished second. Alright, so this program that I'm going to show you guys will be involving the GPU, or these next couple programs. So let's just go ahead and, so I'm going to be demonstrating two programs, a checkerboard program and a smiley face program. Now, as you can see here, this is smiley face program is on core 2, so you just select that, and then to select the core, you just toggle it on and off. It's a T flip-flop. So, and then what you do next is that you set your program speed. So then to do that, you flip this lever down, and then you input the binary value of the speed you want. So this here is 40 ticks, 100. And now if we, this will save our change. And see it lagged a little bit there. All right, so now we will just go ahead and turn the computer on. And this will go ahead and draw a smiley face on the screen, as you probably could tell. And then after that, it'll just shut the computer off. So if we just wait a little bit, it should start drawing our smiley face, and it's starting to lag a little bit because it's the GPU so laggy. But there you go. There's our first point, and there's our second point. And then as you can see, it'll continue to draw the rest of the smiley face. As you can probably see, I'll just let it finish here. Okay, there we go. So it just finished, and as you can see, that was particularly fast. And that's probably the fastest speed you can run this GPU at, as the GPU controller is a very interesting, it's an interesting design, and I'll show you, or it's not interesting, but I'll just show it to you after this. So, all right, so that was a smiley face program, and now I will show you the checkerboard program. Alright, so for the checkerboard program, we are first going to select which core we want to run it on. So we're going to go ahead and load core 1. As you can see, now core 1 is loaded, and the speed, we can change this to 50 ticks, which is 010, and then save that. And now we just go ahead and turn the computer on again. Now, this program takes full advantage of this gray bus right here, and the smiley face program did, but this program, the checkerboard, will take much more advantage of it than the smiley face program did. So as you can see, we are starting to see some activity, and it looks like our image is starting to take shape here. And if we just let it render out, there we go. So there's our checkerboard. Now, as you can see, that was pretty fast, and there was a lot of data in that image, and that's what this gray bus here is for, is to quickly communicate large amounts of GPU data to the GPU, or the plotter, sorry, so that we can have faster GPU draw times like that. Now, that only took actually 2 lines of code, which is, I think that shows the power of this gray bus as well, so that instead of drawing every single pixel of this checkerboard one by one, you could just mass draw large amounts of data onto this screen. So yeah, that was the checkerboard program. Alright, so now that I have shown you guys some programs and some comparisons and stuff versus the Redstone Computer 3.0, I guess I will give you a look at the components of it, or at least I think I already gave you guys a tour, but I want to show you guys the debugger center. So down here is the debugger center, and now this will be used if you actually want to program on this computer, which is it's a somewhat challenging feat, but it's not that complicating, but once you get it, it'll be easier. So what you do is that you just read these notes here, and then basically you just flip the switch to turn on debug mode. You turn this on to manually turn on the computer, and then you use this command. You use this command to increment each line of code manually. And now note here is that the GPU can be unstable if you use cores 3 and 4. Now, right before releasing this video, like this is the second take I've taken of this, the whole GPU controller just failed on me, I guess. So yeah, as you can see here, I redesigned the whole thing. It's a lot cleaner now. There used to be wires everywhere and stuff. So yeah, now this is basically the entire GPU controller from here all the way there, and then also from here, this part here, or more like all this pink stuff and this green stuff over here. So yeah, this GPU can be somewhat finicky, but if you use cores 1 and 2, you should be totally fine with using the GPU. And cores 3 and 4 are still completely capable, but yeah, I just recommend to use a GPU on cores 1 and 2 if you want to program with this computer. So this computer will be in the description for a download, and it'll have these 2 programs on it, and yeah, so that you guys can tinker around with it and stuff. And yeah, I think that's pretty much it. Okay, so those were the demo programs again that I showed you guys to, well, one, to debug the computer, since having a computer this massive and this complicating with so many things going on requires a lot of debugging, and trust me, that took a long time. But yeah, those programs were to help me debug and to also show you the full functionality of this computer. So yeah, if you guys want to experiment with it, play around with it, I will put a world download in the description. And again, this computer can do a lot of other things than just what I showed you, but that, I think, encompasses like a general perspective of what this computer can do. And yeah, I think that's it for this video. If you guys liked it, please make sure to let me know. And yeah, because I've been working on this for quite a long time now, and it's quite an architectural upgrade from the Redstone Computer 3.0, adding a bunch of new features and stuff. And yeah, so if you guys want to see any more content with this computer, just let me know in the comments. If you guys have anything to say, let me know in the comments. Just put your feedback in the comments, guys, because I read the comments and it makes my day, so even when I'm busy and stuff. So thank you guys very much for 200 subscribers again. Thank you guys for watching this video. And until next time, guys, see you later. Bye-bye.